Okay, good evening. More jelly beans. Gotta finish eating these off to the side, and we are going to do lesson 3 video notes, growth and decay. Here's our learning targets. We can explain growth and decay of an exponential function in terms of its base, the common ratio of a geometric sequence, the growth decay factor, and the context in the context of a real world problem. So, some definitions. An exponential function is a function of the form y equals a times b to the x. We know that. We're experts at that, where a is not 0, b is greater than 0, and b is not equal to 1. Exponential functions are non-linear. Once again, our general form, y equals a times b to the x. Okay? Where a is the initial value. Remember how we start out with those 17 polar bears or mice, the initial value. B, we talked about being the base. It's also called the growth factor or decay factor. B could also be called, it is really the common ratio also. So common ratio is also the B. X is the time, Y is the ending amount. So we have a couple different ways. We talked about this before. This is increasing, right? It goes from small. Think about money. Put money in a savings account and it grows. So this is called growth. This is what we want. Growth is when that A is greater than 0 and B is less than 1. Okay? So that's the growth. B is greater than 1. Sorry. B is greater than 1 and A is greater than 0. So the function is growth. B is called the growth factor. So this B is also called the growth factor. A represents the initial amount. Here, we have a lot of money and we lose it in the stock market or something. Well, that's called decay. We don't want that. We want our money to grow. We don't want it to decay. Decay happens when A is greater than 0, but that B, remember what happens here? It's a fraction. It's stuck between 0 and 1, so it's a fraction basically. A fraction that's between 0 and 1. That's decay. B is called the decay factor. Okay? So, determine whether the following functions represent exponential decay, growth, or neither. So, what are we looking for? We're looking for this B value. If the B value is greater than 1, it's growth. If it's a fraction between 0 and 1, it's decay. B value right there is 3. This one is growth. Alright, what about B? Here's the B value, 2/3. Well, 2/3 is a fraction that's between 0 and 1, so this is decay. Okay, we have to be careful. It's a fraction between 0 and 1. If you had a fraction like 5/4, well, that's not between 0 and 1. That's greater than 1. That would be growth if it was in there. Okay? So we have to just be careful about that. I think you got some U-tries that will have that, or we'll talk about that later in these notes. Time for some jelly beans. Alright, so identify the decay factor of the equation. What's the decay factor? Well, it's that B value, right? Right there. So the decay factor would be what? 2/7. So we could say B, because that's the decay factor, 2/7. That's all we're talking about. Given the exponential function, identify the initial or original amount if the function represents growth or decay, and then whatever that growth or decay factor is. So we want to know what the initial amount is. What's that initial amount? It's that A value. It's the A value, right? So initial amount is 1.5. Is this growth or decay? I'm going to look at that B value now. Is it a fraction between 1 and 0? Between 0 and 1? 1/4 is. It is decay. And what is that decay factor? Just that number fraction, 1/4. Okay? Initial amount, the A value. Well, it's -6. This is growth or decay. You gotta be careful here. It's a fraction, but is it a fraction between 0 and 1? No. This is an improper fraction. We have an improper fraction. It's greater than 1. That's 6/5. That's really 1 1/5. So 6/5 we could write as a mixed number. 1 1/5. That's greater than 1. So it is growth. And what is that growth or decay factor? It's growth right there. And it is 6/5. Okay, so we got to be careful about that. All right. Now we have some other concepts here where here's our general form, but what's different here, it's got 1 plus r in the middle there and a t where the x usually goes. So this is called our growth model. Growth, because we're adding. Decay model down here, we're subtracting, okay? So let's talk about this growth model. Initial amount is A. The growth factor is the whole thing, 1 plus R. The R is the growth rate, and that T is the time. Okay? So that's going to be important. That's our growth model. Our decay model is all the same except it's 1 minus R. And it's the decay factor is 1 minus R. The decay rate is R. So, we want to identify the percent of growth. Whenever you hear percent of growth, it's the same as growth rate. So we want to know what this R is. Okay? If we had to write this equation, this is growth, so y equals A times 1 plus R all to the T. So the A is 5. They're talking about what the growth rate is, the R. But this has 1.43. So 1.43 is the whole thing. That's the growth factor. So 1.43, I could really say that 1 plus R equals that, because this growth factor is here. I want to find out what R is. So how do I solve for R? Subtract 1 and subtract 1. R equals 0.43. That's going to be my growth rate. Okay? So maybe you don't have to do this all the time, but we know on the growth rate, we're going to subtract 1 from it if it's a single number. So the growth rate is 0.43. If I ask you what the growth factor was, it's 1.43, the whole thing. Okay? Let's try another one. Here's the growth. Why is this growth? It's a fraction, but it's an improper fraction, so it's greater than 1. So how do I find this R? Well, I know I'm going to subtract 1 from it. So it's going to be 5/4 minus 1. We can do that on the calculator, and we get R equals 1/4. This is my growth rate, 1/4. Because I really set up 1 plus R equals 5/4 and then subtract the 1. Okay? So like I said, exponential decay. Exponential decay is going to look like what? This. Our growth is going to look like this. So when we're losing money, decay, we have the same model, but it's 1 minus R, 1 minus the decay rate. So I want to find that decay rate. This is really y equals A times 1 minus R all to the T time. So 0.6, that's my decay factor, but I want to find the decay rate, so it's 1 minus R equals 0.6. I want to solve for R. Whoops, sorry about that. So 0.6 is my decay factor. I need to solve for R. I want to find the decay rate. So, I can do a couple things here. I could subtract 1 from both sides. Subtract 1. I get negative R equals When I do this, 0.6 minus 1 is going to give me a negative 0.4. Okay? A negative 0.4. Can we see on this calculator? So 0.6. Oops. 0.6 minus 1 gives me a negative 0.4. Okay? But this is a negative r, so I got to multiply or divide by a negative 1, divide by a negative 1, and I get r equals 0.4. Okay? That's my decay rate. Alright? I'm going to take this, and I can say 1 minus this to get my decay rate for a shortcut. So let's do our shortcut over here. Here's it's decay because it's a fraction less than 1. So my shortcut would be 1 minus 3/4, which equals 1/4. That is my decay rate. Did the same thing over here. Here's the math behind it. Here's our shortcut. To find our decay rate, we say 1 minus whatever that decay factor is. To find the growth rate, we take the growth factor and minus 1 from it. So a little bit different. Growth factor minus 1 for the growth rate. For the decay rate, 1 minus the decay factor. Okay? Still got some jelly beans. Grab some. Alright. Example 6. By looking at the graph, identify if it's growth or decay. Let's talk about money. I got money, and I start losing it. What happens to my money? Well, it's decay. I don't want that to happen. I don't want my money to decay. I want it to grow. This is growth rate. Growth, right? Decay, growth, we talked about that before. So, let's do a word problem. Population of mice in Gus's backyard triples. We're going to do our same thing. I see that word doubles, triples, quadruples. I'm going to underline it every month. At the beginning of June, there are 3 mice at the beginning at initial value. So, my A is 3. My B is 3 for the triples. Right? So, it says write a sequence that represents the number of mice in the backyard. Show at least 4 months. So maybe we don't have to do that here. We're just going to write a sequence. We start with 3. Alright? What if it triples? What do I get? Well, I get 9. And then it triples again. 9 times 3 is 27. 3 times 27 is 81. It triples again. So I'm tripling it. 0.3, 0.3, or times 3, times 3. Right? So this is my answer. It's asking for 4 months. First month, second month, third month, fourth month. You just show 4 numbers. We could make up that general rule and plug it in and find it in our table, calculator, however we want to do it. What's the common ratio? Common ratio is the B value. Common ratio, they're looking for the B value. So the common ratio is 3. Does this sequence represent exponential growth or decay? Explain why. Hopefully we know it's growing, that mice population is growing. Why? The values increase over time. So they increase, that's growth. Alright, that's it for our lesson tonight. After watching this video, you can, what can you do? What still don't you know how to do? And if you don't know how to do it, what are you going to do? Anybody know what they're going to do? Let's see, we are going to what? We're going to ask for had it queued up. That's what you're going to ask for. Let me know if you know that song and who sings it right on the top tomorrow. See you tomorrow. Bye.